All right, let's go. Okay, hey, if you're not subscribed, please subscribe. Don't forget to throw me a like, and there's a free PDF in English y Espanol. So please download it, give these problems a go, and then come on back and see how you done. Okay. This is Algebra 1, single variable word problems. We got variables on both sides, kiddos, variables on both sides. This is our practice. All right, let's refer to the given word problem. 6 more than 4 times a number is equal to 12 less than twice the number. Okay, so I'm going to let n equal the number. Okay, because that's my unknown, right? So unknown means variable. So n is the number. 6 more than 4 times the number. 6 more than, this right here, 6 more than means that you're going to add 6 to something. So that's what 6 more than means, right? If I have $10 and you have 6 more than me, 10 plus 6. What are we adding 6 to? We're adding 6 to 4 times a number. So that looks like that. Now this word is an important word in word problems. That word is, which always means the equal symbol. So, equals to 12 less than. Okay, if I'm 12 less than something, then that means I start with a value and I take 12 away. So I'm 12 less than, and what am I 12 less than? I'm 12 less than twice the number. That's it. That's my equation. So 4n plus 6 equals 2n minus 12. Now I'm going to find out what that number is. So I'm going to do inverse operations. There's no distribution over here. There's no distribution over here. So I always look left and right, see if I can simplify. If I cannot, I now move my variables to the left, simplify that, move my constants to the right, and I'm going to rewrite that up here if it's okay. Negative 12 minus 6 equals negative 18. And then the last thing I'm going to do is divide by positive 2. And now I have n equals negative 9. All right, let's see how we did. Here's how I can see how I did. I'm going to go to my equation that I wrote, and I'm going to put in negative 9 for my n. So I'm checking. That gave me negative 30. Now I'm going to go to the other side, and I'm going to put in negative 9 as well. Negative 30. So that must be the number, because it makes both of my expressions the same value. Let's go. All right. You start a savings account with an initial balance of $52. Okay, so that's an initial amount. That's like your y-intercept in a slope-intercept form, right? That's your initial value. And you save $12 per week. All right, that's like your rate of change. And I know that because of the per. So this looks like I'm going to take 2 linear equations and set them equal to each other. Your friend starts an account on the same day with an initial balance of $128 and saves $8 per week. And now here's the question. How many weeks will it take for them to have the same amount? So how many weeks? So we're looking for time, weeks. All right, let's write our equation. First, I'm going to let W equal weeks that we have been saving. Okay, let's write our equation. I have an initial balance of $52. That means I start with 52, and I add $12 per week. My friend starts the account on the same day, so I want to know when are they equal. Balance of $128 saves $8 per week. That's my equation. 52 plus 12W equals 128 plus 8W. All right, let's solve this. Again, I'm noticing there's no distribution, no combining like terms. I always look for that first. I'm going to move my variable term to the left, rewrite it. Now I'm going to move my constant terms to the right, Rewrite it. It's okay. I'm going to go up here. Okay. 4W equals, 128 minus 52. Is that 76? It is 76. Let's go. Okay, the last move is divide by 4, and I get W equals 19. So I'm going to say 19 weeks. All right, I'm going to check that answer. So I'm going to go to original equation, and I'm going to plug 19 in or substitute 19 in, however you want to say it. There's numerous ways to say it. We'd have $280 after 19 weeks. Let's hope that my friend has the same amount. Woo, they do. So that worked. How much money will you have? Oh, I just figured that out. $280. Make sure you use unit of measurement on all of your word problems. All right, let's keep going. My dog, woo, my dog, woo. My dog weighs 2 pounds. Okay, so weighs 2 pounds, okay, and gains weight at a rate of 1.75 pounds per week. Okay, this is very similar to the problem we just did. My uncle's dog weighs 12 pounds and gains weight at a rate of 0.5 pounds per week. Per month. Ooh, sorry, I keep saying week, per month. How many months? There's the question, right? Always look for the question because that dictates your variable. Okay, here we go. So, M equals the number of months that my dogs have been gaining weight. Okay, let's write an equation. So, dog starts off at 2 pounds. Okay, that's the initial amount. And the rate, that's how I change. So 1.75 pounds per month. That equals 12 and 0.5 pounds per month. Okay, that's my equation. Write down. So 2 plus 1.75 M, where M is the number of months they've been gaining weight, equals 12 plus 0.5 M. Let's solve it. All right, inverse operations, because again, there's no simplifying, so I can't distribute, cannot combine like terms. Minus 0.5 M, minus 0.5 M. Simplify that. 2 plus 1.75 minus 0.5 is 1.25. That's like $1.75 minus 50 cents equals 12. Now I'm going to subtract 2 from both sides. And I'm going to get 1.25 M is equal to 10. Divide both sides by 1.25. I'm not sure this is going to happen evenly, but let's check it out. So I have 10 divided by 1.25. Oh, it did happen. 8. Okay. That's awesome. So 8 months. Okay, let's check to see if it's true. So I'm going to go to my original equation right here. Original equation, 2 plus 1.75 times 8. That's 16 pounds, big boy. 12 plus 0.5 times 8. Woo, that's it. It worked. How much will your dogs weigh? 16 pounds. All right, let's go. Moving on. Here's the back side now. Distance equals rate times time. Okay, this is a very common formula. It's a great formula. So distance equals rate times time. I'm going to highlight this formula because it's going to be very important for us. Okay, so we got to figure out some distance, rate, and time. A bicyclist travels at a rate of X miles per hour. Okay, so that's my rate. Okay, so I know that's going to be my R. Up a mountain and 8 miles per hour faster. Okay. This is still a rate. Down the mountain. Okay. The trip up the mountain took 3 hours. Okay. So up the mountain was 3 hours. and the trip down the mountain took 1 hour. Okay, so that is my time. Okay, so let's talk about what we have. We have up and down the mountain. Okay, so up the mountain. Okay, so if I'm going to go over here, I'm going to go up the mountain. The distance equals x, because that's my rate, times 3, because distance up the mountain is equal to the rate times the time. So the rate up the mountain was x miles per hour, and the time it took was 3 hours. I'm going to write that a little differently. If it's okay, I'm going to write that as 3x, because x times 3 is 3x. Okay, now let's talk about down the mountain. Okay, so down the mountain, it took 8 miles per hour faster down the mountain. Wow. So that's my rate plus 8. They were flying. Now, because that goes together, it's kind of one value, I'm going to lump it together with parentheses. And that took a total of 1 hour. And that, again, is being multiplied because rate and time. Okay, what do I know? I know that the distance up the mountain and the distance down the mountain is exactly the same. So I can write an equation where I set my rates and times equal to each other. So I'm going to say, because that distance, which is 3x, is equal to that distance, I'm going to substitute 3x in for there. Equals x plus 3 times 1. That's my equation. Now, what is x going to give me? X is going to give me the distance. That's right. That's right. Okay? So, distribute 1. When you distribute 1, it doesn't change anything. So, it's just that. All right, now I'm going to subtract x from both sides. So, subtract x. That gives me 2x. Oh, that was messy. Subtract x. That gives me 2x equals 3. Now I'm going to divide by 2 and divide by 2, and I get x equals 3 over 2, or 1.5. Okay? So, a bicyclist travels a rate. Solve the equation to find the distance from the bottom to the top. So, here's my equation. I can just use this. And then the distance is 1.5 miles. All right? Okay. Yesterday, that's it. We're done. Yesterday, I parked my car on the top of a hill and ran down at a rate of x miles per hour. Okay, so you're at the top of the hill, and you had a rate of x miles per hour. That's going downhill. My rate going up the hill, all right, so again, we're talking about a rate. My rate going up the hill was 4 miles per hour slower. Okay. The trip down the hill, so here's down again, took 30 minutes. And the trip up the hill took 1 hour and 30 minutes. Okay, we got a little bit of a problem here. And the problem is our units of measurement need to match. So notice my rate is in hours. So my time needs to be in hours as well. Okay, so think about that as you do this problem. Okay, so the distance downhill, so distance equals, downhill is a rate of 4 miles an hour, or x miles an hour. So that's my rate, x. So I substitute that in for my rate. Remember, the equation we're using is distance equals rate times time. Okay, so downhill took me 30 minutes, but I need to have my unit of measurement in hours. So 30 divided by 60 is 0.5. Okay, and if I write that, where I actually multiply those values together, I get that. Okay, now we're going to go uphill, like so. Uphill, I'm 4 miles an hour slower. So my distance uphill is x minus 4. I'm going slower. My rate decreased by 4 miles per hour. and it took me an hour and 30 minutes. An hour and 30 minutes in hours is 1.5 hours. That's that. That's that. Remember, so distance up, distance down, this value and this value represent the same number because the distance up the hill and the distance down the hill is the same value. So I can substitute all of this in for that d. So 0.5x equals x minus 4 times 1.5. Okay, let's solve this. We have distribution here, so we're going to have to deal with that distribution. 1.5 times x is 1.5x. 1.5, well, first of all, negative times a positive is a minus, negative. And 4 times 1 is 4. 4 times 0.5 is 2. So 4 times 1.5 is 6. Okay, good job. Now I'm done simplifying. So I'm going to move my variables to the left. And that gives me negative 1x equals negative 6. Divide by that negative 1. And I get x equals 6. All right. Oh, sorry, I didn't write my equation. I'm going to write my equation as 0.5x equals x minus 4 times 1.5. Okay, now I have 6. Solve the equation, find the distance from the bottom to the top. So one direction is 6 miles. That's it. Done. I'm going to check it real quick just to see if my distance will be the same, or if the values will be the same on both sides. That's that. Good. 1.5 times 6 minus 6. Woo, that's good. Okay, so that's great. That gives me confidence that I did it right. Okay, my mom and I left our campsite by canoe and paddled downstream for an hour and 15 minutes. So downstream, hour and 15 minutes. Okay, that's my time. At a rate of X miles per hour. Okay. There's that. The trip back took 3 hours and 45 minutes, okay? At a rate of 3 miles per hour slower, so they must have been going upstream on the way back. Boy, that's a rough one. I always like to go upstream on the way there and downstream on the way back. All right, write an equation. Remember, we're talking about distance equals rate times time, so distance equals rate times time. So we have two distances. We have a distance going downstream and a distance going upstream. So downstream distance is equal to my rate is X. Okay? It says right here that paddle downstream for an hour and 15 minutes at a rate of X miles per hour, and the time. This is where we got to convert that time to hours again, because notice my rate is in miles per hour, right? So I got to convert everything to hours. So I have 1 hour, but how many hours is 15 minutes? 0.25. So that means that's 1.25 in hours. I'm going to rewrite that with my value in the front. Boom, like that. Okay. Now let's go upstream. Okay. Upstream, I have a rate of 3 miles per hour slower. So my distance upstream is the rate downstream minus 3. And it took me 3 hours and 45 minutes. So I know I have 3 hours, but what's 45 minutes in hours? It's less than 1, so it's going to be a decimal. So I take the number of minutes and divide it by the number of minutes it took me, divided by the number of minutes in an hour, and that will give me the number of hours. So that's 0.75 hours. but I'm going to add 3 to that. So that equals distance equals rate times time. Distance equals rate times time. Now what do I know? These distances are the same. So that distance and that distance represent the same value, the same number. So I'm going to take all of this and I'm going to substitute it into here. Now I have an equation I can solve for x. And when I solve that for x, that will give me the distance. Okay, let's do it. I forgot my x. I'm going to put it right there, if that's all right. Okay, so distribution, 1.25x is equal to 3.75x minus, is that going to be 12? No, 11.25. I don't know what I'm doing. Oh, I did it, but yeah, okay. 11.25. All right, now I'm going to subtract, right, because I want to move these variables from the right to the left. So I'm going to subtract that from both sides. And I'm going to go up here. I get negative. I better use a calculator on this because it's early and I feel like I'm making mistakes. 1.25 minus 3.75 is negative 2.5. X is equal to negative 11.25. Divide by negative 2.5. And I get x equals, negative divided by negative is positive. That's good because I can't have a negative distance in this situation. So negative 11.25 divided by negative 2.5. That's 4.5. Okay? So distance is 4.5. But, ooh, they tricking me. Solve the equation to find the total distance traveled. Okay? So upstream was 4.5 miles. But downstream was also 4.5 miles. So together, that's 9 miles. Ooh, I almost didn't see it. Okay, kiddos, that's good stuff. Distance equals rate times time. I'm loving it. Okay, stay strong, be great. Make sure you get those devices put away. Clock it and lock it, my people. Clock it and lock it. All right, stay strong. Bye.